Hello there, it's Jay here from Jay's Vintage Junk, and today thought we'd get on and test the colour monitor from the S-4000. Now, as you know, when we looked at this previously, we can't just plug this into the mains and try it, because this thing was designed to run on 100 volt AC supply. So what we're going to do is we're going to use, let me grab him because he's heavy. We're going to use this thing. Let me just unhook that and I'll get the camera down so you can actually see what we've got here. Right. Basically, what we've got here, this is my variac. This is a variable AC power supply. So essentially, what this thing will allow us to do is you put UK mains in there, which is what, 230, 240 volts. Ours is much closer to 240 than 230. In there, then using that dial, you can basically dial in any AC voltage from supposedly 0 volts, although this one is a little bit volty. It doesn't quite go down to 0, but that's not going to affect what we're doing. So essentially from 0 volts there, and you can actually crank it all the way up, way past your line voltage, and this thing will actually output up to 400 volts AC. So it's a very useful piece of kit. It's not a toy. You've got to be very careful with pieces of equipment like this. This is a little bit more than your average variac. I mean, this came out of a lab, hence why it's, like I say, this is in like a proper heavy duty case. It actually does have a circuit breaker built in, as well as a line input fuse. We actually have a display on it to tell you what the voltage output is. Generally speaking, you just use, with the cheaper units, you just use a tester, a voltmeter or something. It's built in on this one. Those are replacements. Originally this did have a really nice like ceramic built-in socket there, but so I got this second hand. It was ex-lab equipment, and that had been smashed on it, so hence why it's got that socket there, but that's by the by. That's what we're going to use to produce our 100 volts AC. So I'll put that just slightly off shot. You'll probably still be able to see it actually. We're going to have that there. We won't plug it in just yet, but I'll get that ready for plugging in. Now, at the moment, what we've got on that end is we've actually got a US style plug, so obviously we can't plug that in there. That's not going to work. I could just chop that off and put a safe block on, just put my safe block straight on there, but at the moment I don't know how I'm going to actually power this thing up permanently, so I'm not going to hack that off just for yet. What I did, well, what have I done with it? What have I done with it? Oh, there it is. I pulled that actually out of the S-4000. That's that US style socket strip. Quite a nice little unit itself actually, so that's now going to be part of my test equipment. So what we'll do, just move some stuff so I can get in this drawer. We've got my safe block there. Get the correct tools out that we're going to need. We've got the safe block there, so that will plug us into the variac like that. Let's have that right down. Open that up. I don't know if you've seen these before. It's just a really simple, safe way of connecting wires to the mains. So if you've not got actually a plug on a device, you literally just put the wires underneath there. You've got your live, neutral and earth in the middle there. You can have a correct whatever fuse you need. I've got a 3 amp in this up in the top there, and when you shut it down it energizes. So basically it's for testing pieces of equipment that don't have a UK plug on them. Very handy piece of kit. So what we'll do, we've got that US plug there. We've got the end, let's just sort this out because we don't need them spade connectors on the end. Let's get rid of them. Okay, so we've got 3 wires now, and this is the US colour code, so we've got white, black and green. So this is where it's a bit confusing compared with the UK. I'll just get these stripped off, but white here is our neutral. So white goes to blue. The black there is our live. Bearing in mind that in the UK, black is one of our old neutral colours. It is actually a live colour in the new 3-phase system, I believe, though. Well, I'd left the industry really when that was coming out, so I'm not too sure on the new colour codes for 3-phase. I think it's black, grey, brown. I think it is. Anyway, that's irrelevant for this this conversation. So we've got live, neutral and earth there. Just strip that off. There we go. Right. So we can connect that to the safe block. There's the safe block. So we need black to brown. Just press it in like that. Make sure it's down. White to blue. Make sure that's nice and tight in there, and green to green. So that's our earth. So basically that's it. That's the US cable connected through the safe block. Shut that down, and that's going into the variac there. You can now plug the monitor into the other side of that, like that. So that's the monitor energized up. I will plug the variac into the main supply. Just bear with me. Now the variac is off at the moment, and the control on it is turned right down. So we'll plug that in. We'll switch the variac on. You see it's come up. It's showing about 80ish volts, because I said this variac isn't perfect, but it does work. We will bring that up to the 100 volts by turning it up on there. So that's, we've got 100 volts basically going in there. And have we got any, and actually these, it is working. I believe this is really seized, but let's have a go. We actually do have a raster on the screen. It's a little bit dim, but it's a little bit out of focus, but we do actually have a raster there. Let me see if I can get this brightness pot to adjust. There we go, because this brightness pot isn't in a very good condition, but... Ah, there we go. It's not too bad. There we are. Now it is it's a little bit soft by the look of it. And I can see a few scan lines just going up and down the screen, but it is working. We do seem to have a working screen there. So the only thing being that currently the only way we can power it up is via the variac. Right, let's shut that off. We'll turn it off. That seems okay. What I want to do now is a quick test. I didn't shut myself and I just caught a nerve in my shoulder, so don't be alarmed if you saw me jump back like that. So I just pulled a nerve in my shoulder. What I want to do, let's get us round to the back and I'll get you focused in. Let's get that out of the way. That's the brightness control. I can disconnect that for the moment. Just get that out of the way. Let me get you zoomed in. Right, and what we want to pay attention to is this. I'm not actually showing you what I'm pointing at there, am I? There we go. That connection there. Because basically what that is the AC from the isolation transformer in the monitor to the main board to power it. Now, as we've said on the previous video when I was talking about this monitor, this is an isolated monitor, fully isolated. It uses a double wound mains transformer over here, that thing there, to basically step down the 100 or 110 volts, sorry, 115 volts AC to a lower AC voltage to actually go onto the main board, which then goes through a bridge rectifier and what have you to actually power the monitor. So to convert this monitor to run on 240 volts, all it would be a case of doing is replacing that transformer. But what we first need to ascertain is what the secondary AC output voltage of that transformer is. So what we're going to do is we're going to disconnect the transformer from the main board there. So basically we'll have a low AC voltage on that connector. We'll get a test meter. We'll set it to AC. There we go. I'll set that to 200 volts AC. But it's going to be nowhere near that. It's going to be... Can I get that so you can see it? Yes, we can there. It's probably going to be 24 volts, 30 volts, something like that. Let's have a look anyway. So I've just literally just connected from the secondary output of the mains transformer there straight to the meter. So basically what I'm going to do now is I'm going to power the monitor back up through the variac with 100 volts going into the transformer, and we will see what the secondary output voltage is there, and then we know what transformer we need to actually be able to drive this monitor off a 240 volt input. So without further ado, let's switch on. Oh, that's a lot higher than I was expecting. Right. So that's a step-up transformer. That's interesting. This is not what I was expecting. I was expecting that board to run on perhaps 30 volts AC into that bridge rectifier, and no, we're getting around the 150 volts mark there. So that's out of the secondary on that transformer. Right. That makes it a bit harder to do what I was initially planning on doing, actually. We will have to think of another way of actually, if we want to use this monitor, of actually powering it. Because like I said, I was expecting that voltage to be perhaps 22 volts up to like 30 odd volts, something around that kind of ballpark. I was not expecting it to be 100 and around the 150 volts mark. So anyway, we'll switch back off there now and disconnect there. Right. Well, unfortunately, I feel that what that means is it's going to be quite difficult to just substitute that transformer straight out. What we're probably going to have to do then, let me get you zoomed out a little bit. Oops. Sorry about that, folks, I caught the camera as I was trying to get out. Basically what we're going to have to do then is use a step down transformer to step the 230 volts, 240 volts down to 115 volts, and then use that to feed that transformer. Fortunately, this transformer does have a tapping on the top to swap it between 100 volt primary and 115 volt primary, so that basically the monitor was designed to run in either Japan on the 100 volts or the US or 115 volt country as well. And it does have a tapping on the top to adjust that, so we can make this so it's a genuine proper 115 volt monitor. We can then possibly use a 240 volt to 115 volt auto transformer, step down transformer. That will get us the 115 volts, and we've still got the isolation transformer in here to make the monitor 100% safe. So if we do want to actually pursue this monitor and go that way, I think that's really what we're going to have to do. Otherwise we're going to have a variac sat on top of the thing actually just powering this monitor, which isn't really a practical thing to do. So at least we've seen that the monitor kind of powers up and does something. The next thing I really want to try and figure out is where we can actually get a signal, something into this monitor, and actually see if we can get it to display an image. So what I'm going to do, I'm just going to quickly set the camera back up for a slightly better view, and we're going to have a look at seeing if we can identify what the wires, basically, what these wires do. And then we can figure out about actually getting something up this thing and see if we can actually get an image on it. So back in a sec. Right, okay, here's the idea what I've got. See if we can figure this out. Obviously we've got the 5 wires that we're interested in there, and I've got that video amplifier board, so this might actually help us and identify those wires, because basically what we've got is we've got 3 video amplifiers, which will be for the red, green and blue, and they're actually marked. That's a great thing. So we've got the red video amplifier, the green video amplifier and the blue video amplifier, like that. And then this here, I'm actually suspecting that this thing takes composite sync in, and actually this circuit here splits it into the horizontal and vertical sync. At the moment, that's what I'm actually thinking is happening here. Possibly I might be able to do something like that myself, to have a standard single composite sync input, or the separate HSync and V-sync. Again, if we actually decide we are going to do something with this monitor. So let me hopefully this is yeah, the battery has just failed in my in that tester. Just bear with me a second, folks. I'm just going to have to sort a different tester out. Just bear with me a sec. Sorry about that, folks. I did know that battery actually needed replacing. I've been meaning to do it, and it finally died on me. Anyway, we've got something we can use here, and it's actually a bit louder. That's more like it. Right, so the idea is going to be now, one of these capacitors, I hope you can see this, one of these capacitors, either the electrolytic or that, is probably going to be the blocking capacitor for that actual colour for that video stage. So now that is the red. So let's try. In fact, let's try here first, on the end of that electrolytic there, and we'll just see. Let's just make sure. Oh, I'm gone. Well, that finds all of them, so it's no, but that goes between all of them. Let's try over here. Right, there we go. So that ceramic capacitor there is the blocking capacitor. So we have, right, what we need to do, we need to mark this, pin this out now. All the grounds go to the back, so let's just draw this out now. Oops, like that. Right, so we've got, basically I'm just drawing out what that connector looks like, really basically. I won't do it perfectly, but so we've got the brown there now, and we've got the ground there. So all the ones at the top there are ground. So basically, and I know for a fact, I looked before, on the bottom of the board they're all linked together, so we just have one common ground going throughout the whole thing there. We've got a brown wire there, and I think that is either going to be +5 or +12 volts to actually power this board up, so we don't need to worry about that too much. That's just VCC, let's call it. The ones that we're interested in is that one, that one, that one, that one, and that one. So we'll start from that end there. Now, where was we? We was on that ceramic capacitor there. Now I think them first two are probably H-sync and V-sync, and then the next one, right, that's red. So we know for a fact that that wire there is our red. Now this one is, this should be green. We'll try the same thing, so we'll go onto that capacitor there. We'll try the next one along. That was the one that was on red, and we're not getting anything on there. Let's try the next one. Nothing there. Let's try the next one. Oh no, let's try that one again. There we go. So it is the next one along. So we've got green there. Let's try the next here. So this, if this is working right, that should be blue. No, perhaps not. So that must be one of the sinks. Let's try over here. Let's try there. So it's just not. Sorry. There we go. I just wasn't getting a good enough connection. So we are right. So we've got green, red. We missed one out. That's blue there. So we've got blue, green, red. So them two at the end must be our horizontal and vertical, but we don't know which one's which, unfortunately. But we do know that one of those. So those two there are H plus V. So there our H plus V sync is those two, but we don't know which way around they are. But we do know where I'm losing my glasses again. We do know where our blue, green and red inputs are. So basically I think what we can do the same thing on this side of the board. If we actually did want to use this video amplifier, I don't know if we're going to need it or not. I'm not actually going to try it straight away. I'm just going to feed a signal straight into there. But we could play with this board in the future. I mean, it has got the potentiometers to actually vary the amplification per channel. It could be a handy board to mess with in the future, and it, like I said, possibly it does take in composite sync, and then using this it splits it to the H sync and the V sync. Again, that could be quite handy. I think what I will do, I don't want to cut this cable up just yet, especially if we want to see if we can fiddle about with it there. So I'm going to see what I can do about making a lead off to come off this, to connect this monitor up to something. And what I'm actually thinking is, I was trying to think what I could try this monitor on. I was thinking, could I use a PC and for like CGA, because CGA is basically just red, green, blue with a H sync and a V sync, and see if it'll support CGA. But then it got me thinking. I thought, I wonder if I should try an Amiga up it, because I mean, an Amiga, again, we've got RGB, and an Amiga can either output a composite sync signal, or it can also output H sync and V sync. So I'm going to have a fiddle around. I've got my Toshiba T1000 laptop. That's got a CGA output on it. So we could see if that would work, and see if this thing will support like CGA graphics, well, CGA video resolutions. Or we could try putting an Amiga up it and see if that'll work. I don't think we'd actually damage any of the computers doing that, because like I said, this is isolated. It's we're feeding a signal into the monitor. It just wouldn't work. It just wouldn't show actually a display. But those are the two things I'm thinking, possibly the first things to try. So I'll try and set something up. Like I said, I'm not sure yet. I'm going to have to go away and have a bit of a ponder and a think. and I'll either come back with the T1000 and we'll try that, or we'll come back with an Amiga of some description and we'll try that, and we'll actually see if we can get something up on screen. Like, I'm not promising it's going to be perfect or perfectly in frame or anything, but I'll have a fiddle about now and see what we can do about actually getting an image on the screen. So back in a sec. Right, okay, we're back. I've been fiddling and messing about for a couple of hours now, and at first, like I said, I was thinking about trying hooking a CJ up to something that outputs CJ, and I thought CJ doesn't have that. This mouse doesn't have that bright pin that CJ outputs. So although it might have worked, it wouldn't have worked correctly. So I thought I will dig an old Amiga out and we'll have a fiddle about. Anyway, I dug an old Amiga out. And I got the RGB and the H-Sync and V-Sync pin out for the video lead. And it's an absolute lash up, but I've basically lashed that up through a bit of edge connector to the monitor. And I'll show you what I'm getting at the moment. So I switch on the Amiga and we switch the power on for the monitor. We'll let it warm up, and basically what you can see here is all I can get. I have tried the H-Sync and the V-Sync pins both ways round, and it doesn't make any difference at all. Obviously we've got something coming through there, and if I was to reset the Amiga, I will have to switch it off and back on because the keyboard doesn't work on this Amiga, but I turn it off, turn the Amiga back on. You know, it is actually recognising a signal. The problem is, whatever frequency this monitor runs at is not the frequency that the Amiga outputs. So that begs the question, what is this monitor? What frequencies is this monitor actually meant to work at, and is it indeed PAL? It could very well be that this thing's expecting a RGB NTSC kind of signal, or NTSC I'm not really well up with how NTSC and RGB kind of coincide. I don't know if there's going to be any issues like this, or not with like frequencies and synchronization and stuff like that, because obviously that Amiga there is outputting a PAL signal. Well, it's but it's RGB, isn't it? Is that going to cause any issues? I don't know. I also don't know if that's going to cause an issue or not. But all I can say at the moment is either this monitor has got a fault with it, which we don't know, or it is not compatible with the output from that Amiga. So I think I'm going to have to call this like a part 1 of 2. What I might do, actually, is have an investigate of that board and see exactly if we can figure out what that board does, whether that can make us any better on. Anyway, so yeah, as far as we've got, at least we can see that, you know, the CRT actually looks reasonably bright. That I don't think I've got it cranked all the way up there. It's got a little bit more to it. So I mean, it's not exactly in its first flush of use, that CRT, but it's not knackered. You know, it's usable. It is still in a usable state. We're just going to have a look, see what we can do. It's a bit of an odd one. That I was hoping it would work with a fairly standard signal, but obviously it's going to be a little bit more complicated than that. So I'll probably have a bit of a fiddle with that board, see if we can possibly get that to do something. And we'll come back and we'll have a part 2 on this monitor and see if we can get a little bit further on with it. But at least, like I said, we've got an image on the screen. We've got some, well, not an image, but at least we can see a raster on the screen. It is sort of kind of working. It's just it's a bit of a shame we've not got it a bit further on than that. Anyway, I'm going to leave it there for now. I hope you enjoyed this little updated video on the project. So, thanks for watching and goodbye.